Welcome to Definition 2, Right Triangle Trigonometry. And we're going to get right to it in this lecture. That sine of the angle A is defined as the opposite over the hypotenuse. So A over C. Cosine A is the adjacent over the hypotenuse, B over C. Tangent is the opposite over the adjacent, A over B. And cotangent, of course, is the reciprocal of the tangent, so B over A. Secant is the reciprocal of cosine, so it's going to be C over B. And cosecant is the reciprocal of sine, so C over A. Of course, the last three, when we use a calculator, we have to use the reciprocals of the first three. Otherwise, our calculators usually don't have cotangent, secant, and cosecant on them, so we have to use the reciprocals of the first three. The cofunction theorem states that a trigonometric function of an angle is always equal to the cofunction of the complement of the angle. That means that we take sine A, and that is the same as cosine of 90 minus the angle A, as long as A is an acute angle. And when we look back at this at the triangle that we have up here, where we have sine A, for example, and then we would have cosine 90 minus A. Well, B here would be the cofunction, I'm sorry, the complement angle, and then of course sine A comes out to be A over C, and cosine of B, which is the same as this one here, cosine of B equals, well, cosine of B then would be the adjacent of over the hypotenuse, which is A over C, which is the same. Then, and that's what the cofunction theorem states, then cosecant of A is also the same as secant of 90 degrees minus A, and tangent A is the same as cotangent of 90 degrees minus A. And then I guess I could put in a degree sign here somehow. Get it from somewhere. There, there, and there. Okay, I put in here graphing calculator because I just want to test a couple of values. So for example, we're going to determine sine of 10 degrees, and then we'll have cosine of 80 degrees, 90 minus 10, and see that they equal, and we do the same thing for cosecant and secant. So let's do that. So I said sine of 10 degrees is 0.17, cosine of 80 degrees, 0.17. This is not a proof, that's just checking some values. Also, when checking such values, it's good not to use the special angles that we have, like 0, 30, 45, 60, and 90 degrees, but something else. So 10 degrees would be just fine. Tangent of, let's say, 20 degrees, for example. So this here. Cotangent of 70 degrees. Well, the only way we can do this is by 1 divided by tangent of 70 degrees, which is cotangent of 70, 0.36 again. And let's say the secant, which is, let's say, 25 degrees. So a secant of 25 degrees. And then the cosecant of, divided by cosecant of 65 degrees, and again 1.10. Again, that's not a proof, that's just checking some values that indeed the cofunction theorem seems to be correct. Okay, let's go back to Word. Okay, memorize the exact values. The exact values are given from the adjacent and the opposite. And of course, we have become familiar with them from the special triangles that we had in the last chapter. The sine of 0 degrees is 0. The sine of 30 degrees is 1/2. The sine of 45 degrees is 1 over the square root of 2, or can also be written as square root of 2 over 2, and I will do that here. Square root of 2 over 2. Sometimes this is written as such. Watch this. Square root of 1 over 2, which of course is just 1 over 2, and square root of 4 over 2, which of course is 1. And notice the nice progression here. 0, square root of 1 over 2, square root of 2 over 2, square root of 3 over 2, square root of 4 over 2, and then we can abbreviate this one, of course, to 1 over 2, and we can abbreviate this to 2 divided by 2, which is 1. For the cosine, it's just the opposite, so it goes backwards. Let's see, square root of 4 over 2, square root of 3 over 2, square root of 2 over 2, square root of 1 over 2, and 0. They're just the opposite of each other because when we look at the triangle, for small angles, the adjacent is very large, and so the cosine is going to be large. Well, for small angles, the adjacent is relatively small, so the sine itself is relatively small. And for large angles, it's just the other way around. Again, we may want to abbreviate this here to square root of 4 over 2, of course, is 1. And square root of 1 over 2 is simply 1 over 2. The tangent comes out to, again, looking at special triangles, to be 0, and then 1 over the square root of 3. And then 1, and then square root of 3, and then undefined. And these values need to be memorized. We can use the graphing calculator and figure out those numbers. I'll just check them here for the sine relatively quickly. Clear this, clear this. Actually, this is what I'm going to do. I'm going to put 0, 30, 45, 60, 90 into a list. Store list L1. And then I take the sine of list L1. And what we come up with is 0, 1/2, the square root of 2 over 2, the square root of 3 over 2, and 1. And we can check the 2 in the middle here, the square root of 2 over 2, indeed is 0.707, as we saw a moment ago, and the square root of 3 over 2 is 0.866. For the cosine, it would look as follows, just backwards, as we had written in the table. For the tangent, Oh yeah, I see what went wrong on this one. It doesn't like to take the tangent of 90 degrees because that would be undefined. So I'm going to do the following. I'm going to make a new list here of 0, 30, 45, and just 60. Okay, now I made a mistake. It's supposed to be squiggly parentheses. And now store these as list 1. Take the tangent off list 1. And now we finally got it. 0.577. 1, that's at 45 degrees, 1.73. When we look at the square root of 3, that indeed is 1.73. And when we look at 1 divided by the square root of 3, that indeed is 0.577. And with this, I finished the lecture. And as I said, memorize these values.